Thank you, thank you. Welcome. So actually, I'm happy to hear any questions at any moment, so I can stop my slides at any moment and answer questions if you want. So just show up. So how to make your Java tests great again? That's the question. A few words about me. I'm a software developer from a company Codeborne from Tallinn, Estonia. I love unit tests, test-driven development, clean code, agile, extreme programming, pair programming. We use pair programming in our company. I love open source. I maintain few of like famous open source projects, and one of them is Selenide. Yeah, here is my contact data if you wish to contact. I will also publish this presentation on Twitter soon today. So today's plan is three items. Why Java is dying, how and two basic parts: the generic advices how to keep good code in Java. Okay, and specific advices for one specific framework called Selenide. This is like my framework. These two steps basically, and questions if you want. So let's start from Java, which is dying. Have been dying for many years already, right? Have you heard it? During last 5 years, basically my pain is that many projects, many people are migrating from Java to JavaScript. For me, it's pain because I love Java and I don't like JavaScript. So this is me frustrated. What are typical reasons why people are migrating from Java? I mean, especially in testing projects, in projects where they do write tests. They typically say that Java is verbose, that Java consumes lots of resources, that Java tests are slow, and so on and so on. So JavaScript is faster, that JavaScript has better syntax, shorter syntax, and so on, is more readable. Or they just want to learn some new technologies and apply in their projects new technologies. And probably the most important reason nowadays is, what is the reason? Of course, Playwright. There happened at Playwright 5 years ago, which is a great framework, primarily created in JavaScript. And probably this is number one reason why people do migrate their tests to JavaScript. And that's my pain. Let's discuss all this in details. I claim that actually Java can be simple, fast, easy, concise, readable. It can be. It's doable. You just don't need to complicate things. Let me bring some examples. The problem is that during last 25 years or even more, there were written tons of very bad Java code, including Java tests in the world. They were written because of stereotypes, bad tutorials, misleading information, fake information, bad habits, poor frameworks, and so on. So yes, there is a lot of bad Java code, but it does not need to be bad. Actually, it may be better. So think critically. Today, I want you to revisit your vision of Java code or Java tests and think again how it could look like. So, do you know this principle, KISS? A little bit modified, yeah. Keep Java code simple, stupid. Please, let's check some examples. So we start from generic part. How to keep Java tests simpler, shorter, better, more readable. Some generic advices, not depending on specific libraries. Project structure. Let's start from project structure. I see a lot of projects, testing automation projects that contain folders source main Java and some packages, and source test Java and some packages. People often put in source test Java, they often put tests, and in source main Java, they often put some page objects or page help or test helpers, formatters, and something like that. This is bullshit. Sometimes the problem is even worse because people even split their projects to modules. You know, Gradle and Maven allow creating sub-modules, sub-projects, and they split project to model and model to source sets, main Java, test Java. This is even worse. Actually, this all can be simplified. You can just put everything, all tests, all page objects, everything in source test Java. You don't really need modules and source sets. And if you need to organize, of course, you need to organize files. If you have a lot of files, just use packages. Just put files into sub packages. That's it. You don't need anything more. Yeah, just historical information that source sets, I mean source main Java and source test Java, actually were intended to have different dependencies. The whole point was that main Java has some dependencies, and test Java has some other dependencies, JUnit, for example, or Selenium. That was the point of different source sets. You actually don't need it in tests. You always have JUnit and Selenium, whatever, in tests. That's it. You need only one source set. Modules. Modules were intended initially in Java world to produce different jars, to build different jar files. Model 1 jar, model 2 jar. You actually don't need it in tests again. So simplify your project structure. Next topic, build scripts. It's very common for people to write build scripts in Maven, and usually it looks like blah, 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 very, very long XML. It's really long, right? So why not use Gradle for it? Gradle syntax is much shorter, basically like 2 lines of code. It does exactly the same. Plus, Gradle has better test report, not this surefire bullshit, but just readable report which you can open and read. So yeah, aren't you tired of this boilerplate in XML format? It's not better in any way. Getters and setters, next topic. I have to speed up. Yeah, it's very typical to write Java code like this. You have class, you have private fields, you have getters and setters for all fields. Again, it can be simplified. It should be simplified. And many people often say, hey, you don't need this getter setter. You can generate them in IntelliJ with shortcuts, or you can use Lombok. You can use Lombok to generate all these getter setters. And yes, you know, people usually add tons of annotations to classes. It's sad for me. Actually, no, please don't. It's not really needed. Lombok solves the problem that doesn't need to be solved at all. The proper solution is just to throw away this garbage, just to delete this garbage. Getters and setters are evil. They are not really needed. Nowadays, if you use latest Java version, you just create record with just fields, and it's short, it's readable, it's usable. That's it. Do you know? Yeah, people say that, hey, direct access to field is dangerous. It's bad. No. Only using getters or setters. So I claim that calling getter or setter is not safer. It's not safer than accessing directly this field. It does not bring any benefits, any security, nothing. It's not useful. People often say that, hey, if we access field directly, it's not OOP. It's not object-oriented programming anymore. But if you have getters and setters for all fields, it's not OOP also. It's not object-oriented programming. Because one of key principles of OOP is encapsulation, which means that object must expose behavior, but hide implementation. Expose behavior, hide implementation. Which basically means you should not have getters and setters, because getters and setters expose implementation. You have to have public methods for behavior, not for getter setters. Sometimes it's okay to have DTO objects, like only to transfer data without any behavior. In this case, like getters seem reasonable, but that in this case, public final field is also okay, or just record is also totally okay. Get setters anyway are not needed. Just historical information that getters and setters were invented or were created actually many years ago for, who knows, initially for using in desktop GUI components in programs like NetBeans, which scanned all getters and or setters and allow and build UI for building like Swing components like UI, where you could fill all these fields which are correspond to getters and setters. Later, this principle started to be used in enterprise Java beans, and you know what? These technologies died many years ago, probably 25 years ago. They are not used anymore. So getters and setters are not needed anymore for a long time. What happened? So the next topic, I have to speed up. TestNG versus JUnit. People often use TestNG. People often like TestNG. And again, it's sad for me because TestNG, typical test, looks like this. You need to declare a field. And you need to have before method which initializes this field. It's very typical. Like immediately lots of lines of code. Compared to that, if you write JUnit test, it can be much shorter. JUnit test can be just like this. Just one field. That's it. You don't have to have like before methods and so on. Just declare a field and immediately initialize this field. This is possible because the key difference between TestNG and JUnit is that TestNG creates one instance per class and reuses this instance for all these test methods. That's why you cannot reuse the same like field. You cannot initialize this field only once because it will be reused in next tests, and it can, like one test can affect other tests. Compared to JUnit, which creates a new instance of test class for every test method, which means that it's totally safe to initialize fields and so on immediately in the field declaration. It will not be reused in the next tests. So it will be safe. Tests cannot affect each other. So in case of JUnit, it is safer and shorter. Just use JUnit. It's my warm recommendation. Suite. Okay, well, if you still use TestNG, people usually tend to create XML files, suites, like one or multiple suites, which contain names of your Java classes or names of your Java packages. And again, this is so old school. It was used in older versions of Spring Framework also, that you had to create Java files and you had to create XML files which contains reference to Java files. It's just not needed. Do you really need this XML? Are you sure? Actually, no, you don't need XML in TestNG. You can have just a bunch of old good Java files in the project and just one dependency declaration in your POM XML, and it just works. You don't really need all these XMLs. I have working example on GitHub if you want. Just think about it. Yeah, maybe there are some cases where you need different suites with different parameters, different thread counts. Maybe, but in most cases, it's just not needed. Okay, let's keep this one because we don't have too much of time. This is Makito. Somebody is using Makito? Oh, okay. This is for you. When you usually when you write unit tests, you often declare a test like this. You extend your test with extends with annotation, and all the fields you annotate with @mock annotation. And again, this class becomes quite long. Instead of this, it's much easier to again initialize field, to avoid using annotations at all, and just initialize every field in the field, right in the field. This is much shorter, much simpler to track. Not needed any complexity with annotations, extensions, listeners, and so on and so on. it has some drawbacks actually, but yeah, we can discuss details later. Anyway, it's shorter and easily readable. And yeah, my last word in this part is about over-engineering. People often tend to over-engineer, not only QA engineers, developers also, even more probably. So my wish is, please stop building your frameworks, your testing frameworks. QA engineers love creating their own frameworks. They are proud of their frameworks. In most of the cases, it's just reinventing the wheel. It's not really needed. Because we all actually are paid for what? For solving business problems. Business needs us to solve some problem, and we do solve this problem. And we are not paid for reinventing the wheel, right? If there is already exists some good library in the market, just use it. Don't reinvent it. Don't write custom solution. Please no. We are not paid for building custom frameworks that already exist in the market. Yes, not needed. We are not paid for introducing new technologies in our projects just to learn them. This is what we often do, right? Hey, Puppeteer, let's use Puppeteer. Hey, Cypress, let's use Cypress. Oh, Playwright, let's use Playwright. Just to learn new technologies. Just ask yourself, is it really needed for business needs? Yeah, it's called resume or CV-driven development. Please don't. You can learn all these technologies, but at free time, or I don't know, at some learning time, but not in real project. Over-engineering. Yeah, this is just one small example. When people do create their frameworks, they actually, again, tend to over-engineer it. They tend to create too generic solution, too complex solution, like too wide solution for all kinds of situations that will never happen in your project. This is just one small example. Once I saw a method, I had to debug actually this method, understand why it's not always working. Method called wait for element clickable. It has two parameters: locator, timeout in seconds, which is in very strange like form, like with 3 dots, right? And this method does something like this. It does some attempts, up to 2 attempts. It waits for something. It checks some seconds. It uses 30 seconds by default. So quite complex code. Try, catch, break, loop, whatever. Quite complex code. And after thinking on it, about it, after analyzing it, I came to a conclusion that it can be simplified. It can actually be written in just one line, just like this. It does exactly the same. So instead of over-engineering and creating some complex code, think twice. Think, can I create simpler code? Can I use existing functionality already? This is actually what makes us wise. Not creating complex code, but creating simple code or readable code. Yeah. And in case of Selenide library, this code uses Selenium library. And if we use Selenide library, this is the same code, would be even similar. Just one line of code. Actually, in Selenide, this line waits for an element for a few seconds if needed and clicks it. This code does exactly the same. Or if you need custom timeout, like 30 seconds, you can, yeah, set timeout. So we are getting closer to my favorite child, to my library, Selenide. This is specific. Who is somebody using Selenide in their projects? Aha, brothers. Thank you. So Selenide is open source, free library for UI tests in Java, for web UI test or mobile UI tests in Java. I created it many years ago. I love it and I promote it. I highly recommend you using Selenide if you write tests in Java. So my motivation, why I came here, this is my pain, because I often see this problem, not problem, I often just see that during the last 5 years, people often decide to migrate their tests from Selenium, which is in Java, to Playwright, which is mainly in JavaScript. Actually, it has adapters in Java and Python, but yeah, mainly it's used in JavaScript, which like makes me sad. And why people, how they explain why they decided to migrate? They often say that it's JavaScript. JavaScript is faster, more lightweight, more readable. This is typical. Also, Playwright allows me to write tests for a mobile, which is funny, and so on and so on. There are different reasons. So let's try. Not of this is true. Not always true. Let's try to analyze. First of all, this is basically is a wrong comparison. When people say that Playwright is better than Selenium or is faster than Selenium, it's a wrong comparison because these are different tools. Playwright is a tool for testing, while Selenium was never been a tool, has never been a tool for testing. Selenium is not a tool for testing. Selenium actually is a low-level tool for manipulating browser. It's not a testing framework, not at all. So you don't have to compare them. And actually, there are testing frameworks or testing libraries built on top of Selenium. There is a bunch of them. One of them is Selenide, probably the most popular in Java, and there are a few more tools in Java and .NET and Python and so on. So I'm talking about Selenide and Java. Selenide is a tool for testing. Open source library built on top of Selenium for testing, which means it contains concise API for tests, for assertions, for checks, and so on. It has functionality to make your tests stable, not flaky. It can take screenshots, videos, everything that is needed for tests. Like Selenium does not do it by default. It's not for testing. Selenide has a lot of matchers and so on and so on. Actually, a lot of functionalities, some reports and so on. So the right comparison is compare testing tool with testing tool. So you should compare Selenide or any other testing library on top of Selenium. Here is a list on Selenium site, Selenium ecosystem / frameworks. So you have to compare one of these tools with Playwright. This would be the right comparison, the fair comparison. So now we're talking. Now we're talking. Let's compare like similar tools, testing libraries. Let's check syntax. They say that Java syntax is verbose. Java is long. Java is not readable. Let's check. Today I asked ChatGPT to generate a simple hello world test for Playwright, and ChatGPT generated like test like this. First of all, for me, all this endless awaits in every line, like, isn't it verbose? Is it okay for you? I don't like it personally. And let's compare how tests in Java in Selenide looks like. This test does exactly the same. Opens a page, the web page, finds elements and clicks it, and checks that some other element has some text. This is essentially the same test. So do you still think that Java is more verbose than JavaScript? Really? No, really? Of course, it's just a hello world example. In some other cases, there might be different results, of course, but still, it's like comparable, at least. It's not that Java is like tons of code and much longer. Not at all. So, how to make your Java tests? I mean, like if you assume that you have Java tests in Selenium and you want to make them better, yeah, how to make your Java tests great again? This is my key topic. Let me bring some simplifications or code example how you can improve your tests if you use Selenide library or some similar library. If in Selenium you had a code for finding element, which usually looks like this, finds element and clicks it, then in Selenide it would be much shorter, just $element click. Does exactly the same. If you want to assert element visibility, checks that element is visible. In Selenium, usually you had to write something like that, assert true, find element is displayed, like quite a long code. In Selenide, again, it's much shorter. Dollar finds an element and should be visible, checks that this is visible, like readable. By the way, the code on the left side is buggy. It contains POC. Can you spot it? Is displayed. Yeah, true. Is displayed is tricky, but actually visible also uses the same method inside. Is displayed. Exactly. Yeah. Good. Yeah. Correct answer. Find element actually fails, throws an exception if the element is not found. So this assert true will be either true or throw an exception. It would not. It will never be false. So this code should be rewritten actually. So all these nuances are already fixed and considered in Selenide side. If you want to assert that some element is not visible, how to do that in Selenium? You cannot just call assert false find element because it would throw an exception. So what people usually do is call find element and check that there was exception thrown. So quite long of code. There are some options as well, but still you need to think about it. Like you need to write this code or copy paste. Again, in Selenide it's much more simple. You just write element should not exist or should not be visible, depending on what you need. Waiting. It often happens that your tests are flaky or failing sometimes because some element is not immediately visible. It is being loaded for a few milliseconds, or this element does not immediately have some expected text or color or class. You have to wait a little bit sometimes. So often you need to add some waitings to your tests. In Selenium, it looks like this, usually. Actually, it's readable. You have to say that wait until element like gets visible. Like quite okay, but in Selenide, again, it's not different at all. It's just the usual check, like element should be visible. And the whole point is that you don't even need to think about it. Do I have to wait for something? You don't even think about it. You cannot forget to wait because Selenide already can wait out of the box just by default. So your tests, most of your tests are not flaky anymore. They cannot flake like time to time because Selenide will wait, just will wait out of the box. Or if you need some custom timeout, you also can specify this timeout as a second parameter for all these should be or should have checks. Just to highlight this topic once again, any of these methods, like mostly any of Selenide methods, can wait if needed. By default, up to 4 seconds. 4 seconds is the default timeout. So if you write element should be visible, Selenide will wait for 4 seconds if needed, if it's not yet visible. If you write should have text, Selenide will check, or we still don't have this text. Okay, let's wait a little bit. And so on and so on. All these checks will wait if needed. And of course, this timeout 4 seconds is configurable. You can set any other timeout if you want. Error messages. What you always needed in tests, you have to have good error messages explaining what happened if the test failed. So typical tests in Selenium looks like this. You write assert that some element contains some text. But the problem is when this test fails, when this element does not contain this text, you want to know what was the actual text, what was the actual state of this element, did it has some ID or unexpected CSS class or something like that. So how to know all this information? And what people often do, they often add logging to their tests. Often write log info, that was element text, or probably you have to write that was element class. So all these logs are heavily spamming your tests. And what is even worse, you cannot know beforehand what more information should you log? Probably you should you would want to log all attributes of these elements or CSS class of this element. You don't know. So when another time when your test fails, you will need to get back to this line and add some logging and more logging. So this is disaster for me. Lots of unneeded boilerplate in code in your tests. Compared to that, what does Selenide? If you write something like that, like some element should have text, then Selenide will automatically generate a code error message containing all the needed information. So for example, this line, if it fails at some moment, it will produce a good readable error message, which contains the element itself, the expected text, the actual state of elements. This blue line actually contains all attributes, all classes and text and so on of this element. So you can later inspect what happened actually to this element. And also Selenide does automatically take a screenshot, saves a page source. Sometimes it can save even a video if you configured it, and attaches all this information to the error message. So when your test fails, you get all the needed information. You can immediately investigate what happens, why the test fails. Next few topics. Collections. Sometimes you need to check like many elements. People often start using soft assertions for that. In Selenide it's much easier. Again, you can use a method called $2, which returns a list of elements. $, returns one element, the first one. $2 returns list of elements, and you can check all these elements at once. For example, you can check that you have 3 errors on the page, or you can check texts of multiple elements at once. For example, using something like that, you can say that $2, like list of elements, should have texts and multiple texts. Very convenient to check like multiple elements. So which again makes your test very expressive, very short, very readable. And the benefit is also when this test fails, you will see actual text of all these elements. So you can compare them probably when they load it in different order, for example. Also, you can filter these elements using method filter. Yeah, and a lot of methods more, a lot of possibilities. Video recording. You can easily enable video recording for any of your tests or for all tests, how you want. For example, often you want to record the video for some specific flaky tests that sometimes fail. You can enable video recording just by adding annotation add video to some specific tests, and you don't need to run any like Docker, Grid, or test containers or whatever, what usually people use for recording video. You don't need it. You just run play tests and Selenide will record the video if this test fails by default. You can configure a video recording so that it will generate video for all tests or only for failing tests, only for specific tests, but by default only for failed tests you will get the video. And when you have this annotation and this test fails, then link to the video will be attached to the error message as well. So you run test, it fails, you can click and immediately watch the video. Maybe I can show how it works. Let's run a suite of 3 tests without any XML. We have 3 tests that run in parallel in 3 different browsers, and we see that one of these tests actually failed. This test failed because we actually don't have this element on the screen, and when we check the error message, we will see that element not found, expected was this text, and you can click on the video and watch the video. That's it. So what we have, couple of slides more, I guess. In Selenide you can find elements by text. This is one more thing that Playwright promotes actively, that you have to find element not by ID, not by some technical internal details, but by visible text, like real user. And in Selenide, it has been possible for more than 10 years already. It was always possible. You just can call methods by text or with text, which finds element by the whole string or substring. So it was easy. And soon we will release a version with method by label as well. It will be ready soon. Yeah. And if you want to learn more about Selenide or its functions, you can contact me if you wish, or you can check some videos. For example, the video from last year's TestCon when I showed like in details more features of Selenide, all this file uploading, file downloading, reports, and whatever else. Or you can check another video where I described how you can migrate your existing code from plain Selenium to Selenide, like step by step. And now I'm open for questions.
Thank you, Andrei. Can you hear me? Yeah.
Yes.
Thank you. Yes, so we are ready for questions. Let's see what we have.
Okay.
When using Java records to store API request fields, what is your recommended way to handle optional fields?
Doesn't matter. You can make optional fields nullable or use like optional class in Java. What is your preference? How do you like it? Most probably I would make them nullable. Yeah. Nowadays we have a very convenient library, JSpecify, which allows you putting nullable annotations to fields or methods or parameters.
Then I think it's like a classic question. Is Selenide faster than Selenium? Does it initialize browser session in the same way?
Yes, Selenide uses Selenium under the hood. So technically Selenide uses Selenium and is same fast as Selenium. But Selenide has some tricks, some methods or some settings which allow to make your test faster. Because we analyzed what are the slowest operation in Selenium. For example, the slowest operation is like filling some text fields, and we did optimize it using some JavaScript hacks and some other hacks as well. So you can enable settings to make things faster than in Selenium. Yeah.
Thank you. Can this be used for testing an app that runs on Android and iOS, not web application? Or which tool will you suggest?
Yes, Selenide allows you writing tests for mobile applications, definitely, because Selenide integrates with Selenium and Appium. So in Selenide, you can even reuse the same test for web and mobile versions if they are similar. Or you can, for example, write a page object in Selenide with 3 annotations: find by, Android find by, and iOS find by, and reuse this page object for 3 different tests. So yes, it's totally possible. Yeah.
Okay, great. And well, the final comment is that it was the best talk on TestCon so far. Thank you for positive feedback. Thank you, Andrei, so much. Now I think it's time for one of the most exciting part of our event in general. In the events, it's lunchtime, guys. Time for networking. Please get to know each other, talk with your favorite speakers, and be back in approximately 1 hour. We will continue with a few more speakers. Thank you so much.